I think we have our initial session. We have understood very high level what is generative AI and what does how the overall, very high level in terms of how it holds in terms of the text going inside this. So we will just move a step back. Okay, and now we will start our journey a little step back in terms of from the to understand the embedding, because most of you are new to this, right? So to understand the embedding, what it is all there, what does embedding means, we will just move a step back and then we will try to see how pre-LLM era, okay, pre-LLM era, when the encoder, decoders and stuff was not there, how the encoding was done, why we will be trying to understand that, because in from that encoding stuff from the pre-LLM era, it will give our concept a clear picture why these embeddings are so important. Because once we understand this embedding, after that we will not focus much on this embedding and consider that anything we are passing on text, it is converted back into embedding. Is that okay? So let's first understand, as I said, we have moved a step back and we have moved into the pre-LLM era. We are trying to find out how the text are got converted into numbers, because as we said, embeddings are a list in Python, which you are seeing is a list of numbers. So each word will be represented in a form of a numerical numbers. We can call them as vectors. Okay, they are represented in the form of a numerical numbers or vectors, and that's why they are said as a list of numbers. Okay, perfect. So if you see these words, I hope you're seeing this. So in a natural language, each line, remember this terminology, each line is called document. Okay, and the set of unique words are called the corpus. Okay, each line is a document and set of unique word is a corpus. Now I have a 3 4 documents here. The food, this was the first initial one. So there are different techniques. One of the technique was one hot encoding. Okay, so these are the 3 sentences or four sentences or 4 documents, I can say. I have food is good, food is bad, pizza is amazing and stuff like that, right? And there's a sentiment analysis. But my objective is not on the sentiment analysis. My objective is how do in the pre-LLM era, these words were converted into vectors or numbers. And one of the very and this comes in interview. That's why we are teaching you so that. And the one hot encoding is one of the oldest, in fact the first methodology, easiest, but it is not the best encoding technique, because it was the initial one and people developed more sophisticated techniques compared to one hot encoding. Okay, now see here how it is done, and that's why it created sparse matrix. The food is good. So what is my unique number of words? This is my corpus. The food is good, bad, pizza, amazing, right? So how many dimension? 1 2 3 4 5 6 7. So 7 dimension is my corpus because I have 7 unique words. You do not have to do this manually. It will be done practically through one hot encoder class is there. Okay. So 7 dimension I have. This 7 dimension is a corpus. Okay. Then each sentences are depending on the number of word. It is causing a matrix calculation 4 cross 7. How? Because I have 4 unique words in this first document and total number of unique word is 7. That's why each sentence are being transformed or transposed into a 4 cross 7 in case of, because I have 4 unique word. So the is represented by this 1000 because the is the first four letter. Rest are zero. Food. Food is the second letter. So 01100 0100000. Ease is the third letter. 001000. Then good. Good is the fourth letter. So 001000. Okay. So my entire D1 is represented by entire this stuff 4 cross 7 matrix. Are you able to understand this? It is easy, but obviously it has lots of drawback. Unnecessary sparse matrix it is creating, lots of zeros. The actual information is very less. Increasing the size of my, if I store this type of vectors, it will be increasing the size of my vector database. So lots of zeros and sparse matrix it is creating. But that is the drawback. Okay, but is the easiest way. I- Have you understood this? How the food is good is represented?
It is 7 by 3,
4 cross 7.
4 cross 7. Yeah, 4 cross 7. Yeah.
It
There are
depends on
7
number of
unique words,
unique
right?
words, number of unique words in that sentence, and also the total number of unique word becomes your dimension.
Yeah.
So the total number of unique word is 7, but in that sentence or the document 1, it has only 4 unique words. So that's why 4 cross 7. Obviously, similarly, food is bad, 4 cross 7. Pizza is amazing, 3 cross 7, because we have 3 unique words, right? So that's why 3 cross 7. So now it is pretty simple, as we could see that what are the advantages? It is easy to implement, but there's more disadvantage. That's why this is not used at all. But this was the initial one from which uh, no other techniques were developed. Okay. So what is the disadvantage on this? The disadvantage is sparse matrix. Lots of zeros it is creating, right? It is very clear that we are creating lots of zeros. Okay. There is no fixed input. Now, one sentence can be of 5 words, one sentence can be of 20 words, one sentence can be of 7 words. So, lots of different input size, which is not ideal actually, right? Because in our deep learning, we know that there should be a fixed input size. So, lots of different input size. Okay, that is one big problem. Now, the major problem was two problem out of vocabulary and semantic meaning. Okay, so this is the last two is the most important one where it is telling out of vocabulary and semantic meaning. Semantic meanings is what? It is not able to capture the context, right? When I say the pizza is good, is it able to capture the context that it is talking about the food? No, right? You're not able to capture the context here. It is just simply like labeling. The words are being labeled either one and zeros, right? It is not able to capture the uh, it is not able to capture the context of them, right? Because it is simply labeling it by 1 and 0. Is it clear? So that is a major disadvantage because in our LLM model, it is all about context. It is all about understanding what in what context I have asked the question. It is all about understanding the semantic. Semantic means what? The inner context of the text which is I'm passing or the query I am passing. It is all about that context meaning, right? If you do not capture the context, then there is no point, right? Is it clear? So that's why it is pretty sure, although the technique we should learn because from there the development happened to other technique, but it is pretty clear that this one hot encoding does not suit our bill because although it is simple, but it is not capturing the context on which the question was asked or the because that is important for our LLM. With otherwise LLM, no LLM will, if the LLM does not understand the context, then how it will be able to do this no semantic search and give you the response properly? Is it clear, guys? Understood the way one hot encoding happens and the advantages and the drawback?
Yes.
Yes, Arpan.
Yes, Arpan.
Yes, Arpan.
Yeah.
Perfect. Obviously, that led to the improvement of another technique called bag of words, and we will see this technique somewhere it is used. But this is also not the best technique, but it is called bag of words. That means here they try to reduce this sparse matrix formation. How? Let us take these sentences or documents, rather we will say as documents. He is a good boy, she is a good girl, boy and girl are good, okay, stuff like that. Now what it does, it does an interesting thing. In one hot encoding, it does not remove your uh, stop words and stuff, right? But here in the bag of words, what it does, it removes your stop words. So basically, it is reducing the unwanted word, that is he, is, the, all those stop words. I'm sure you guys have heard of the term stop words in NLP. So all those unwanted, that, then, all these unwanted words are being reduced or being removed first. So that is what the bag of word technique does. Initially, what they do, they remove these unwanted words, that is stop words, lower all the words, so they perform into lowercase. Okay, okay, they perform into lowercase. Okay, okay. Once it is done into lowercase, then how it is doing the encoding? That means conversion of the text into numbers like this. So in this, now if I remove this circled word, is a, she is a, and are, so what are the words which is remaining? The words which are remaining is this: good boy, good girl, boy, girl, good, right? So good, girl, and boy. These are the three words which is remaining, isn't it? The unique words. Now my D1 or sentence 1 has two things: good boy. So it is just a single list, row of list. It is not creating that big matrix like 4 cross 7. Here you can see the single sentence is represented by a single list 110. Clear? Is it clear, guys?
Arpan,
Yes,
can you
Arpan.
repeat that once more, Arpan?
The first sentence, if I remove the stop word, it has two words, good boy.
Good boy.
And the unique number of words are how many? Three, good boy and girl. So
Yeah.
the first sentence is represented by what? Good boy, because girl is not there, that's why 0. 110.
Yeah.
So it is a definitely an improvement compared to one out encoding where the sparsity is getting reduced. Okay, but definitely the context or the semantic information is not getting captured. Again, it is same 1 and 0, right? It is just labeling. If the words are present, they will be labeled as 1. If the words are not present, they'll be labeled as 0. Just like that, if else condition, right? It is not at all capturing the context meaning, but definitely an improvement. So this new technique was called bag of word. Okay, in Python there is a NLP, there is a class called count vectorizer. That count vectorizer will does the job for us. Okay, this is how it will be represented. Okay,
Arpan, one question here. Can you go a little above? And we have output there, right? 111.
output ignore. Output is just the data set is like that.
Okay.
We are not
Okay.
focusing on the output. That is sentiment analysis. That's why one ignore that as of now. We are focus is on how to convert, how what techniques are there in the pre LLM era, what were there, so that we can understand the benefit or the advantage of post LLM era, how good it has become. And I am sure by the time from starting of the session till now, we are pretty sure the problem area is obviously we need to have a compact vectorization or numbers being representative of the words. Along with that, we should also have uh, it should capture the semantic meaning. That's what we are giving haunting. It should capture the context. Okay. It should always capture the context, which is missing here.
Okay, got it, Arpan.
Sparse matrix was reduced, but it is also does not capture the context. Now in there, they also made an improvement. Okay. What they did, they introduced a term called ngram. Okay, like bigram, trigram. What does that this mean? Now in general, when we speak that, like the second line, when you say the food is not good, just imagine if the machine was reading single word at a time, the context or the sentiment which is there not good, if you read it together, then you will think it is a okay, this is a negative statement, right? And as human we read them, we understand that. But just imagine the machine you're passing and you're telling the food is, it is reading one word at a time. Since it will read not separately and good separately, definitely what will happen? It will not consider the context at all. Okay, it will not at all consider the context. So what will become? It will not able to understand that it is a negative sentiment. So they introduced a term called ngram, and they said while you are coding, you will be able to add this terminology. Okay, you're able to add this terminology of bigram and trigram. Okay, what does that do? That means if you give bigram and you're just selecting this type of parameter 1 comma 2, that means unigram and bigram. That means I'm telling, if I tell it is a bigram, I will combine the two words. All the words will be have a combination. For example, now what is the unique words present? Food not good in this, right? If I remove the and use, the unique word present is food not good. Now I'm telling, okay, these are my single unique words, unigram. Now I want to make it bigram. So what will happen? Every have a combination. See here, food good, food not, not good. So this not good is our interest. So with this, we are checking all the combination so that we are able to capture the objective is capture the meaning or the semantic information we are trying using this. Although this is not great, but definitely it is an improvement from one hot encoding to uh, this bag of word or count vectorizer. Okay, so where now if you see, obviously I'm increasing the dimension. For the first sentence, what will come? Food one, not is not there, good is there, food good, yes it is there, then rest is zeros. Similarly for D1 or say D2 or sentence 2, food is there, not is there, good is there, then food good is not there, food not is there, food not, and not good. So we are able to capture, trying to capture the context or the essence using the unigram bigram technique. You can have trigram also. It is up to you. Experimentation, like combination of three words also you can be, but be careful when you're doing increasing the no grams, ngram, unigram, bigram. What will happen? Your dimension, this dimension, number of you know dimension present, the columns basically, it will keep on increasing if you think like a columnar structure. But in matrix, it is about the dimension. So the dimension, if you will keep on increasing, if we keep on adding the unigram, bigram stuff. Okay, is it clear till here? So we understood two technique, one hot encoding, and these are all part of pre-LLM era. We have not gone inside the pre-LLM, post-LLM era. And then there is bag of words with the combination of unigram and bigram.
The permutations will increase, right?
Permutation is up to you whether you want to give unigram, bigram, trigram. But the more you give, the more dimension will increase, and computationally you have to check. You should be fluent enough. So, but you have to take care of that.
And Arpan, you said this is adopted in bag, meaning bag. You said we have bag of words plus the n-gram, like the combination.
Inside bag of word, yeah, it's just count vectorizer. They have a parameter called ngram.
Arpan, regular metrics and sparse metrics are the same, or
No, regular metrics, they have non-zero values. Sparse metric, they have lots of zero values. That's what we saw in one-hot encoding, and here also you are seeing sparse
yeah, but
metrics means
it
they
has
have
to
lots
be
of
okay. You can have both
lots of
zeros.
zero values does not make any,
Yeah,
just computationally it is expensive, but it does not make any information you're not able to get right from there.
yeah, yeah. But it is n-dimensional only, right?
Yeah. Generally, no, I will not comment on that right now because when we go to transformer, you will see the research paper they took 512 dimension. Just imagine one word will be represented by 512 dimensions. So it depends on your no, and you can modify the dimensions accordingly.
Is it 512 by 512, Arpan, or
One into 512, right?
1 into 512? So one word gets represented using
512
512.
dimension. Yes,
Okay,
that is as per the research paper transformer what they did.
512. Perfect. When the same word gets repeated multiple times in the sentence, like is there a count maintained in in
That you
in
will see. There is something in transformer that in order to combat that, you will see in transformer architecture. There is something called positional encoding. How they combated this same question, what you're asking, you will
uh,
see in our transformer architecture class. Uh, there is a concept they introduced called positional encoding, where there's multiple times words been repeated, but they might have a different meaning on that particular position. So that they can that you can check using this positional encoding that we'll understand in our this class.
okay.
Okay.
And other than one not encoding in all of them, the stop words are eliminated, right?
Stop words, punctuation, lowercase, removing special characters, emojis, these are all pre-processing, cleaning up the data.
Okay.
So that it is common across any technique what you're using to convert them. So that is a corpus creation. So you're creating a corpus where you're trying to clean up this stuff. First you clean up, then the corpus is generated, and then you start doing the conversion from textual to encoded data. Okay.
Meaning when you say encoding data in vector
Vector
data.
numbers, yes, list of
Yeah.
numbers. When I say encoding means I'm converting them into list of numbers. The last one for today, what we'll understand, the third technique is this unique formula wise. They put, they're called TF-IDF, very popular technique, term frequency divided by, sorry, not divided by,
Inverse.
it is like inverse document frequency. Okay. What's the formula? Number of repeated words in the sentence, that number of repeated words in the sentence divided by total number of words in the sentence, that is called term frequency. Quite natural. Number of repeated words divided by total number of words. Okay. Now, if you see here, now if I take this good boy, right? First sentence, good boy, girl, unique thing. How many times the good is coming? Only one time. So number of words, repeated words, only once it is coming. So number of times the words are coming in the sentence divided by total number of words. The total number of words is 2. So 1 by 2, right? Boy is also once, 1 by 2. Girl is not there, so 0 by 2. So 0 by 2 is 0. Okay, this is term frequency. Similarly, sentence 1, sentence 2, sentence 3, you can understand. Now, inverse document frequency, what you are calculating? Log of number of sentences divided by number of sentences containing that word. So this log of number of sentences are 3. Now the word good is present where? In 3 of them. So log of 3 by 3, that is log of 1 is 0. Now boy, number of sentences is 3 and the boy is present in 2. So 3 by 2. Similarly, girl is present in 2 of the sentences. So log of 3 by 2 because number of sentences are 3. Now what will happen now? Now in the sentence 1, good. Now good is 1 by 2 into good here is 0. So 1 by 2 into 0, it is 0. Okay. Then boy, 1 by 2 into log of 3 by 2. Some value it will come. Right. Then girl, 0 into log of 3 by 2. So it is 0. Okay. So now if you see what it is trying to do here is it is trying to con it is trying to change that into a vector rather than 1 and zeros. Okay, yes, there will be zeros, but the one was not giving any meaning, right? One was just telling me, okay, this is labeled, this is that this word is present, so this is labeled, so it is taken as 1. Okay, now instead of that, this maths 1 by 2 into log of 3 by 2, you can see they are trying to get the essence of meaning. Okay, that means they are trying to get the essence of contextual meaning, because this formula, number of word the number of times the words are repeating, okay, and it is coming back, that is nothing but your trying to gauge out the importance of the words, right? It is not the ideal one because we are still in pre LLM era, but what the improvement they tried to do is they they moved out from the bag of words and no one hot encoder. From there they moved out, and they what they try to do, they are moving towards, we can see that flavor, they are moving towards the finding out, giving importance or the weightage to the words. If I know the importance or weightage to the words, this means what? I'm trying, gradually we are trying to find out the importance of these words. So that's why these vectors now it will be zeros and some decimal point values. Although there are zeros that they mitigated in the later part, in the when they moved into deep learning came into the picture, they mitigated that embedding. But they said only having one was not giving me value add. It is just okay, the word is present, label it as one. But that was not the crust. We need to have the semantic information being captured. So you have to capture the semantic information. At that time, they thought, okay, if the word is repeated multiple times, that means the word is very important. Suppose I'm reading a novel called of a king. If the king name is repeated multiple times, then we can say no, that the king is a very pivotal character, right? We can say that. So in order to gauge that, what they did, they use this type of formula. And using this formula, they tried, although this is not the ideal one, but this is one of the technique they tried to convert this text into embedding with the effort gradually moving towards capturing the semantic information. Log is a formula, inverse document. There is a formula they are putting in, log of number of sentence divided by the sentence present in number of sentences the word is present. So boy, how many times? Number of sentences 3, log of 3 divided by boy is present in 2 of the sentence, that's why 3 by 2. So the boy will come log of 3 by 2. You do not have to do this manually. There is a class in Python, but inside, while you're doing coding, you will not understand what is the backend calculation is happening. So if they ask you in an interview, then you should be able to tell pre LLM error They are the three major techniques which was used. One of the oldest one was one-hot encoding. Then the improvement happened called bag of word with ngram. Then further improvement happened where they tried to capture the semantic, tried the best to capture the semantic information using TF-IDF. Okay, that is term frequency and inverse document frequency.